All right, so as people on there can see, we've got the essential questions up, and if you've got those copied down, then go ahead and give me a quick check mark. The rest of us are copying those. Okay, so the other end is ready. Wait about another 30 seconds for this end. And if I have to put them up at the end, I can do that. So while people are copying on this end, what I was saying is that just kind of listen with one ear and get the copying down with the other hand, with your hands. One of the things that you've noticed is a lot of the questions I keep asking is about patterns in math, right? What's the pattern for this? What do you notice about that? And that's because math is all about patterns. It's not some magical thing. Some of the shortcuts that you guys have learned come because of people noticing patterns in some of the mathematics. Unfortunately, the shortcuts don't teach you the mathematics; they just teach you a shortcut. Okay, looks like most everybody's ready, and if you're not quite, looks like there's somebody next to you you could get this from during the work time, or I can come back at the end. So I'm going to go ahead and move on. Don't forget to get this at the end or before you leave, though. All right. Last week we started talking about factoring quadratics, and that's something such as what we have here, where it says factor n squared plus 8n plus 12. This is using the generic rectangle and the diamond problem. So let's see what you kind of remember from last week about doing that. This is kind of a review problem, and if you're not remembering from last week, then I will we'll work this together so you have a chance. I want to see what you remember first before we work it together. All right? So, remember last week we started off by doing this. And so we had this problem right here. And so what went on the top of that? Went on the top of that. Do you remember? And we've got some new people here, so I'm going to have to just go over the top, go over this. So what goes on the top is the coefficient for this, the 1, times this. So this times this is what goes up on top. And what goes on the bottom is this. And remember that whatever goes on the sides, here and here, whatever goes there or there is what multiplies together to make the top and adds together to make the bottom. Let me check here. Okay. So let me just kind of write that in general off to the side here. You may want to add this to your notes. If I have a number here and a number here, those two side numbers multiply together to make this top number, and they add together to make the bottom number in that pattern that we found. Okay? Now, we also found from our quadratic trinomial here how to figure out what goes on the top of that and what goes on the bottom of that. So what two numbers multiply together to make 12, but add together to make 8? Write those down and go ahead and fill in your generic rectangle there. Or not the diamond problem, that's the diamond problem. What are the two numbers that go on the side of that? Everybody has that. Now, 2 and 6 are the numbers. I saw some of you put the 2 here and some of you put the 6 over here. Does it make a difference which side you put them on? No. Okay. And then after that, we're going to go to our generic rectangle, because remember, we're looking at, if we go back to what we talked about before, remember we had those algebra tiles and we found certain things kind of go into certain sections, and we ended up with about 4 sections, didn't we? What went up in, what goes in, if we're looking at this problem right here, what would go in this section right here? What always went in that, goes in that section? For those of you that have been here. We have a lot of new faces today. What goes in that section right there? And it always goes there. Okay, so for those of you that are new, the part that has the n squared always goes there. You'll see why in a couple minutes. What always goes in this bottom section right here? The 12, right. Okay, thank you, Chelsea. The 12 is the part. So the two parts that we multiplied to get that 12 up on top are the two parts that go there and there. Okay? Now what goes here, remember the 2 and the 6 are talking about how many ends we have, and the ends are split between two different sections. They're split to here and to here. So we have to, the reason we did this is to figure out how to split those ends up in those boxes. How are we going to split those ends so that they go in the right spots? So when I actually build it with the algebra tiles, it actually makes a rectangle. And so we saw that it's going to split to 2n and 6n. It doesn't make a difference which box you put it in. So you put it here and here. And once you've got that, then all you have to do is factor. What's the number that you can divide into each of the rows? So what number can I divide each of these by? What's the biggest number I can divide n squared and 6n by? What number do these both have in common? And when I say number, that means a variable too, the letter. Because n, yeah, because the n represents a number, right? So when I say number, it includes the letters because the letters represent numbers. So since I can divide both of those by n, I'm going to put the n out here. Okay. What about the next row? What can I divide both of these by? What? 2. Okay. And that's the biggest one, right? We always want to go with the biggest one. So I've got 2 here. All right. So that's one of the numbers that I multiply with the other number to get n squared plus 8n plus 12. Because remember, a factor means the number that I'm going to multiply to get the whatever I've got, whatever I was given. Okay. Now I can actually divide here, or I can look at the factors again. So I can look at what divides into both of those, or I can say what to get this number right here. What number times n is going to give me n squared? Either way works. So what number should I have here? Yep, because if I think about it, both of these are divisible by n, right? Everybody see that? But also, if I say n times n, that's going to give me n squared. All right? So what about the number here? What number is going to go up here? If I'm going to find the area is 6n, I know the length of one side is n. What's the length of the other side have to be? To get 6n, you have to have 6, don't you? And in this case, it's a positive 6n because I have a positive n here, and this needs to be positive. Also, if you look, these are both divisible by 6, aren't they? Okay. So my factors for n squared plus 8n plus 12 are, and notice I'm going to rewrite it. Don't just leave it on the generic rectangle. You need to actually write it out. N plus 2 times n plus 6. Okay. So n plus 2 is a single number that it's represented by 2 parts added together, but it's a single number times another number called n plus 6. Okay? So an n plus 2 times an n plus 6 are the factors of n squared plus 8n plus 12. Okay? So those of you that were here last week, is it starting to come back a little bit? A little bit? Okay? Let's look at another one. We're going to do lots of practicing of this today. Okay? So, factoring our quadratics. We're going to factor 5a squared plus 9a minus 2. So what was the first thing we did on the last problem? What was the very first thing we did on the last problem? We'll copy that down here. Okay. Now, there's a couple people on the other end have answered the question already. Correctly, by the way, on the other end. Thank you. What's the very first thing we have to do? What did we do last time? Chicken? Okay, good. We did that because we were making what? We were building what? Why did we do that? Let's go back. Where did that go? You're right. Where did that? We did the 12 times the 1, and then where did we put that? In the top of the diamond problem. And then it doesn't look like a diamond right now. If you look with the examples I took from your book, there's like a book, if you go like this and do the outline, it turns it into a diamond. So that's why I call it a diamond problem. Yes, I put that in the top. Now notice, just one little pattern that I want you guys to notice here. If I go this way, although I'm going to add those together to get my quadratic piece. But if I look at that and I multiply it, what do I get? I get 12. If I go this way, and I multiply the coefficients, I also get 12. And I actually get 12n squared both directions if I actually use the n as well. Everybody see that? Which is why we multiply the 12 times the 1 up there, or one of the reasons. There's other reasons as well, but this is the one I can help you with right now to understand because we haven't done some of the other stuff yet and learned some of the other stuff yet. Okay, so the 12 times the 1 there. So what we're going to do for this one, like Jacob said, is we're going to take the negative, we're thinking of that as -2 and a +5. And we're going to make our diamond problem. And what goes on top here? We said multiply the -2 times the 5, so what goes on top? -10. Okay, what goes on the bottom? What's left to use? 9, yeah, so what goes on the bottom is the 9. Okay. So what goes on the two sides? Figure that out. Multiply together to make -10, that adds together to make +9. What are 2 numbers multiplied together to make -10? When you're putting it stuck in the time. Well, there's 2 numbers that multiply together to make just 10 in general, whether it's positive or negative. 2 numbers multiply together to make 10. What do you think? They can't hear you. They can only hear me because you're too far away. So no, people can hear us. People can hear. What times what makes 10? 1 and 10. Okay, what's the other thing that would work? That might work. 2 and 5. All right. Now it has to be a -10, so one of them would have to be positive and one of them would have to be negative to get a -10, right? So if I have 2 and 5 and I make the 5 negative, is that going to work? No, because the answer 9 is positive, isn't it? If I make the 2 negative, is that going to work? Okay, why not? Yeah, 5 minus 2, and that doesn't give me 9, does it? So my other option is the 10 and the 1, and one of them has to be negative. Which one do you think should be negative? Why would the 1 be negative? if we have 9 positives, then the 10 has to be the positive number, right? Because you have to have more positives than negatives, you have to end up with a positive answer, right? Okay? So what goes on here is -1 and 10. Now what's the next step? What's the next step on this? We've done the diamond problem to help us figure out how to split up this part right here. Now we have to build the generic rectangle. So I want you to build and fill in the generic rectangle. Look at the problem before so you think about where the different parts go. Okay, so most of you got that filled in. Just a little thinking, it's going on in your mind, but that's good. Remember the a squared part is always going here. We found that pattern last time. And down here is the -2. And what goes here can either be the 10a or the -1a. It doesn't make a difference as long as they're in one or the other. Okay? So now what? How do we figure out what goes on the outside? Because what I gave you was what goes on the inside. Now I need what's on the outside. I need the lengths of the sides of the rectangle. So what goes out here? That would be up here, right? Okay, so what is that common factor? 5a. They both are divisible by 5, and they're both divisible by a. So I need to bring the largest amount out, right? Okay? I want my greatest common factor there. If I'm going the other direction here, what do these two have in common? What do those two have in common? Anthony, what do you see? Anything? You don't see anything? Yeah, she's right. There really isn't, except there is one number in common. If there's nothing else in common, what number would it be? Mm-hmm. What do you think? Well, 2 doesn't have an A, but that's a good thought. Any number times 1 doesn't change the number, right? Isn't 2 the same as 2 times 1? If I think about it that way, do they have a number in common now? 2 times 1? Do they have a number in common? They have a 1 in common now, okay. And both numbers are negative, so I think I'm going to put, I think it would be a good idea to say -1 here. What do you guys think? All right, so if that's the case, what's going to go out here? If the top there is 5a, what's going to go here? What number times 5a is going to give me 5a squared? 1a. Or I can just write a, which makes sense because -1 times a is going to give me, let's say, the -1 times the a here. That gives me -1a also, doesn't it? They both have an a in common. So I have a couple ways to double check myself here, don't I? To make sure I'm getting the right thing there. How about here? What's going to go here? Jessica, what are those both divisible by? The 10 and the 2? You're close. You're looking in the wrong direction. The 10 and the 2. What do they both? What can you divide into both of those? 2? Okay. And I'm going to put a +2 because if I see this, I see that 5 times the 2 has to be +10, so that makes it work. And this is a -1 times the +2 gives me a -2. So I'm not done until I write this out. So I'm going to write the factors are 5a minus 1 times a plus 2. Okay? We're starting to are you starting to feel a little more comfortable with this? Okay? Hopefully starting to feel a little more comfortable with this, because we're going to try another one. Okay, let's try that one. What's the first thing we have to do? The negative 30 times the 2, it goes to the source. What are you going to do with that? Put it in the column on the top. Good. I think I'm going to go on this one on your own without me helping you step by step. And you can help each other. You don't have to just sit quietly. You can be neighbor and kind of say, hey, can you help me out? Or you can just over each other's shoulders and if you do something stuff, you know how to do it. Some of you that is going to go with the credit too early in the morning, you got your calculators on your phone, and you're using them, and that's fine. Some of you using your calculator on something else. Okay, so a lot of you did a really good job on this. I kind of threw a little twist at you on some of this to see kind of if you were paying attention, but you guys did a really good job with the basic stuff. So there's a little twist with this that you need to kind of pay attention to as you go through problems like this. First of all, when I look at this problem, there's two things you could do. You can do this problem just like it is. Let's do that first, because that's how most of you did it. And you said, okay, here's my diamond problem. So I can figure out how to split those ends apart, because that's the purpose of this, right? How do I split the ends between those two boxes? And you said this was negative 60. And you said this was 2. And then you found that this was positive 10 and negative 6. And it had to be positive, excuse me, that's not 2, that's 4. Thank you for giving me a couple funny faces out there so I knew that I made a mistake. Yeah, even I do that sometimes, and it's not perfect. So we just do it, and go fix it, and go on, okay? So you did that, and you know it had to be a positive 10 and a negative 6 because it was a positive 4. Then you filled in your generic rectangle. And you knew that from our patterns from before, working with everything, that this ends up being where the n squareds always go. And this is where the 1s always go, which is like the negative 30 part. And then we know from our generic rectangle that 10 of the ends, we have 10 ends here. When we split the positive 4 end, we put 10 of the ends here, and we put 6 negative ends here. So we end up with 4 positive ends. And then a lot of you started going through and you started doing the factoring. So if you look this way, you could get a negative 6. And if you look this way, you could get a 2n. How many got that? Okay, good. Somebody get something different? Don't change yours. Don't change yours because you're not wrong. Oh, it should, okay, well, can you see why it has to be a negative 6 from what I'm looking at? Okay. So now if that's the case, what number is going to go out front so I get 2n squared? Get n. And what goes here? Plus 5. Okay, good. Now, I bet not everybody got that. Okay, so some of you probably did this instead. You went out, I'm just going to write these down. You went this way, and you said, oh, that could be a 2n. So I'm going to write it down here. It could be a 2n. And going this way could be 10, right? So you got 2n plus 10 on one side, like this. And then when you look the other way, what times the 2n is going to give me 2n squared? And you said, well, then it's going to have to be n. Some of you decided to kind of factor going this way too, and you got 2n and then a 2n, and that didn't work because that gives you 4n squared, right? So that's why I said this problem's a little trickier, but it's still the same process. So you had this time you had to look at what times the 2n here is going to give me 2n squared. That was n. And what times the 2n is going to give me negative 6n. So that would be plus 3. Okay, how many got something like that? Some of you got that? But those don't look like the same answers, do they? Actually, it's minus 3, not plus 3. Okay? You guys need to. Okay? Those don't look like the same answers, do they? But they are. Because let me ask you this. What does, notice I used the word completely. I didn't use the word factor, just factor this time, did I? I said factor completely. What do the 2n and the negative 6 have in common, number-wise? Can I divide 2n and negative 6 by a number? With the 2, right? These are both divisible by 2. So if I factor out a 2 from there, this becomes 2 times n minus 3, and then that times n plus 5, right? How about if I did it the other way, like this one right here? What are both of those divisible by? What can I divide both those numbers by? Are both those divisible by 2 also? Yeah? Okay. So for that one, I get 2 times n plus 5 if I factor the 2n plus 10, don't I? Times n minus 3. Do they look the same now? Do they look basically the same now? Oops. Is this one the same as this one now, basically, for the answer, even though I reversed the n plus 5 and n plus 3? Yeah, they're the same now, aren't they? Okay. So sometimes you have to do one more step on one of your factors, don't you, to get it completely factored? Or the one thing that I noticed when I looked at it, and it's just because I've had lots of practice, not because I didn't go through the same process you're going through right now, is I looked at this, and what do I notice that all those are divisible by right off the top? Can I divide all those by 2 right off the top? Yeah? Yeah? How many said yes? Okay. So if I do that, so you can either wait till the end to divide something, factor out a 2, or factor out a number, or I could do it at the beginning. And I could say 2 times n squared plus, and so what would the next number be? Think about that. It would be 2n, right? Minus 15. Would that be easier to do the diamond problem and stuff with? That part of the parentheses, would that be easier to do the diamond problem and stuff with? That might be, right? Because the numbers might be smaller and not too difficult to work with. Does that make sense? Okay. So when it says factor, when you're factoring, you have to factor completely. And that means that if you can factor something more, you have to do that. So you can either factor out something like a 2 at the beginning, if it's possible, or I can wait till I get down to the answer, like you did here or there, and then factor it out. Okay? So we go ahead and get it all factored out so we all came up with the same thing on our paper. Right? Okay? So process is still the same, we just add one little twist to it. Okay? So let's try another one of those. Right now, is trying to make it easier yourself before you start. Might be a good idea. Anything that was there. Use your numbers to work with. You have 489 or whatever it is. 489. I think I'd rather use 21. 463. So use 21 for 63. Anything that you have in common? So maybe use it to factor the 3 out first, and then start with the plus. That's what we actually do that, or we say yes, but they didn't actually do that. Reach out to that person. If you can relate that to what we're doing with this here, that's even better. All right. You guys are doing a good job, and you're puzzling through this, and I really appreciate how persistent you're being with all of this, and how hard you're working and you're not giving up on on this. That's really a good thing. So let's look at this. Most of you discovered it'd be a whole lot easier to do this first, right? That's a whole lot easier than that other problem, isn't it? Okay? And so I'm going to use just the part in the parentheses. So negative 21 times 1a gives me negative 21 here. And this is a 4. So what goes on the sides?
7 and negative 3.
7 and negative 3. Most of you have that. Then you went over here. And you weren't sure if I had to go back to the original problem or if I do the parentheses. And so when I was coming around and helping you, we said it's just the parentheses part. Whatever part we did the diamond problem for is what goes in the rectangle. Okay? Okay, and I have to go check. Okay. And so this is going to be the a squared. And your negative 21. And then you've got your 7a and your negative 3a. So this would be a negative 3, right? This would be an a. A times a makes a squared, and a times negative 3 makes negative 3, and this would be a positive 7, it looks like. So what you guys got? You see? Okay. Do you see how I got that, though? That's number one, I kind of looked across to see that they both had a 7 in common, but I also asked myself, what times a is going to give me 7a? It makes it pretty easy. Now when I'm done, I'm not done yet because I have to rewrite this, and I don't want to lose the 3. Now I'm going to put that 3 back back on there. Does everybody see that? The 3 right here, I've got to put back on the answer. So it's 3 times a plus 7 times a minus 3. Okay? Make sense? Okay. Now, because of time, we've got to kind of wrap up. I want you to think about some of the patterns there. There was a couple other things I wanted to do, so I'm going to do those extra, especially a very short extra credit. I'll do an extra credit video or recording for you guys with a few more points. Everybody appreciates some extra credit once in a while, right? Good quality Cornell notes. I will grade them, score them based on the Cornell note rubric under doc sharing. Okay? So the part we didn't get to, I'm going to do a recording on that for you. And I would suggest waiting to do the recording until a little bit closer to when we come back from spring break, because next week is spring break. Now, if you guys are behind on some of your work, unfortunately, you're going to have to get some of it done over spring break. Doesn't mean, okay? Because if you chose to take your break earlier in the year instead of at spring break time because you didn't do the work on some days, then I guess you're going to have to do some of the work on your spring, what's supposed to be your spring break, because you chose to take your spring break at other times, okay? But you do need to get caught up on some things. And then when we get back, not the first Monday when we get back, because that's just a little too soon after spring break, but the next Monday after that. So not the Monday we come back, but the following Monday, I'm going to give you the opportunity to do Unit 3 on Monday if you're behind, and get those units, those tests and quizzes all taken care of. So, and what I'm going to also do is I'm going to open up, except for the quizzes for Unit 3, I'll open up the work, so if you want to go through and do the work and take the notes and bring that with you to show me you've done it, then I'll open the quizzes up on that Monday. But not the very first Monday we come back, but the following Monday. But I won't open the quizzes up over spring break. I'll only open up the work. Okay? If you need to do Unit 3. Some of you don't, because you just got here, but some of you do. Does that make sense to everybody? All right. Have fun in science.